Okay, welcome back. This is Chapter 6, Rational Expressions, and we are going to cover the topic from 6.5 of solving rational equations. I've written the steps out over here on this side, and I want to kind of go through them and walk through. We'll do two examples here. The first thing we want to do is we want to identify the LCD, but that's not for the same reason as adding or subtracting rational expressions. So for instance, if we had the equation x over 3 is equal to 1/6 plus x over 4. I want to identify the LCD, but because this is an equation, we have an equal sign, then I can eliminate the fractions using the LCD. So that's going to be my second step. There are two different ways to do this. You can multiply the entire equation by the LCD, or you can build up the fractions. Previously, you guys preferred building up the fractions, so that's what I'm going to show you. The LCD here is determined by the smallest number that all three of the denominators will go to, or the smallest expression. In this case, they're all numbers. So the LCD here is 12. If I want to make 3 12, then I have to multiply it by 4. And whatever I do to the bottom of that fraction, I have to do to the top. To make 6 12, I'd have to multiply it by 2. So do the same thing to the top and the bottom. And to make 4 12, I'd have to multiply it by 3. So do the same thing to the top and the bottom. Now, once I have all the same denominators here, I'm going to show you the why this works, and then we're just going to do it from here on out. But on the top, then I would have 4x over 12. Sorry, this on the top I have 4x, and on the bottom I'd have over 12. That's going to be equal to 2 over 12, and this is going to be a 3x over 12. When the denominators are all the same, if I took and I multiplied this equation by 12 and distributed that in, this 12 would cancel out every one of these 12s. So all you would have left is the numerators. So when we have the denominators are the same, we can just wipe them out, because if all the denominators are the same, then what's left is just the numerator. So our resulting equation is going to be 4x is equal to 2 plus a 3x. So I want you to notice here that now we've eliminated the denominators. Our third step is to determine the type of equation. If my exponent on my x term, when I've got it in the most simplified form here, is to the first power, which in this case both of these are, then this is a linear equation. And if it's linear, then I want to solve it by isolating x. That means in this case I would subtract the 3x, and I'd get that x is 2. So I get the value of x is 2. Great. So we just did determine the type of equation. It's a linear, and I solved it by isolating x. Now I'm going to check this. Because there is no variable in the denominator, we don't need to look for extraneous solutions. Again, I'll talk about that again in a minute. But if I check this answer and I plug in 2, I get 2/3 is equal to 1/6 plus 2/4. If I make all of these the same again, then I get that 8/12 is equal to 2/12 plus 6/12. So 8/12 does indeed equal 8/12. So that's my check. And the main reason we're going to check though is we're going to check for extraneous solutions. Here we have no variable in the denominator. So when we have a variable in the denominator, we need to make sure that the denominator is not 0. So we could also have an equation. Let's do another one. Let's say we have instead x squared minus 23 over 2x squared minus a 5x minus 3 plus a 2 over x minus 3, and that's going to be equal to a -1 over a 2x plus 1. Okay, so this first step of identifying my LCD is going to be a little harder than the last one, because my last ones were just constant. But to identify the LCD, I need to factor each denominator. This denominator is factored because the x is to the power of 1, and there's no GCF. This denominator is also factored because the x is to the power of 1, and there's no GCF. If I want to factor this denominator, then I'm going to see if there's a GCF, which there's not. Then I'm going to say there's 1, 2, 3 terms, so I'm going to use synthetic factoring. For synthetic factoring, I'm going to do 2 times a -3, and that's going to be equal to a -6. I'm going to be looking for factors of -6. They're going to sum to -5. That's going to be -6 and a +1. I'm going to write those factors over 2 and reduce these fractions, so I have a -3 over 1 and a +1 over 2. That means then that my factors here, if I factored this, are x minus 3 and a 2x plus 1. And what do you know? That's the same factors that are here. So this is the LCD, because this denominator goes into it, this denominator goes into it, and this expression, polynomial, has both of those terms. So I don't need to multiply this fraction or this rational expression by anything, but I need to multiply this rational expression by a 2x plus 1 because it doesn't have it. So I have to do that to both the top and bottom. And this one does not have the x minus 3, so I need to do both the top and bottom times an x minus 3. Okay, so again, we factored, we identified our LCD, took a little bit of work to do that, and then we're using this LCD to eliminate the denominators. When all of the denominators are the same, then I can say, hey, but what's left in the numerator? In the numerator, we're going to have x squared minus 23 in this numerator. In this numerator here, I'm going to take the sign right here and distribute that in. So that is going to be a plus 4x and a plus 2, okay, for this numerator right here. Then I'm going to have my equal sign, and in this numerator here, I'm distributing this -1 in, so that's going to give me a minus x and a plus 3. What's in the denominator, in every denominator, is this term right here, and because it's the same in every denominator, if I just said, hey, I can just multiply the whole equation by this and it would wipe it out. So we're only working with what's in the numerator. Now we're here where we've eliminated the denominators and I have only the numerators left. I need to determine the type of equation. Well, in this equation we have, it's not all the way simplified yet, but you can see here that this is squared, this is to the first power, etc. So because this has a squared or higher, then I am going to have to use other methods to solve it. So this happens to be quadratic. And if it's quadratic, then what I want to do is set everything equal to 0 and factor it. That's how I'm going to determine the values that will make this work. So I want to add 3 to both sides, add x to both sides and subtract 3. Add x and subtract 3. When I clean up all of this, what I'm going to get is x squared plus this 5x here. And I'm going to get -23, -26, and that's going to be a negative, add that 2 is going to be a -24. And that will all be equal to 0. So now that I have this quadratic equation in this form, all equal to 0, I can factor completely. There's no GCF here, and this is a 2-term or 3-term polynomial, so I'm going to use hippobutts. My markers ran out. I'm going to have to use the green one. So I'm going to factor this using hippobutts, and I'm going to say that x plus 8 and then x minus 3. Again, 8 times -3 is a -24. 8 minus 3 is a +5. So here's my 2 factors. What I would have to plug into this factor right here to make this term 0, or this factor 0, for x, I would plug in a -8. And what would make this factor 0 is if I plugged in a +3. So that means that x is, the solution here is that x is -8 and a +3. And you might be thinking, okay, great, we're done. But we've only completed step 3. This check step is to help us make sure that we don't have what's called an extraneous solution. An extraneous solution is a solution that you find in the process of doing algebra, but is actually one that doesn't work. Well, let's talk about why one of these might not work. So if I were to plug in 3 into this original equation, now this is a lot of work, but bear with me for just a minute. So I'm going to kind of skip all of the work here and just show you, let's focus on this expression right here. When I plugged in this 3 that should be a solution, I end up getting 2 over 0. And remember that anything divided by 0 is undefined. Because this 3 makes this expression divided by 0, this is called an extraneous solution. Okay, we can't have this solution because it doesn't work. So even though we did the algebra and all of our work correctly, this solution right here is a no-go. It doesn't work. So I can't have a 3. So we're going to cross that out and say, hey, our only solution here is this x equals -8. Well, is there a shorter way to check for an extraneous solution? There is. What we're going to do to check for an extraneous solution is we can check up front. So when we first started solving this equation, we could have set each of the denominators equal to 0. Since we know that this denominator right here factors to both of these other ones, then really I just need to know what would make this denominator 0. Well, if I plugged a 3 in here, then this denominator would be 0. So x cannot be 3. Right here, if I have 2x plus 1, and I set it equal to 0, if x were -1/2, then this denominator would be 0 as well. We'll show you that. So if x was the value of -1/2, okay, so here I get 2 times a -1, which is a -2 over 2, plus 1, which is a -1 plus 1. This is equal to 0. So if I substituted the value of -1/2 right here in for x, then that would also make this denominator 0. So up front we could say, hey, when I'm done, I can't get -1/2 or 3 as one of my answers. And if I do, I have to not count that answer. So it only will have one solution here, which is the x equals -8.